So the peer reviewers have been liking my videos and lowering my grade because of the watermark, and they keep requesting me to remove the watermark. The problem is, I can't remove the watermark unless I pay this much money. I still have to pay tuition, okay? And this is not enough to convince you to not like my videos or nor to lower my grade solely because of the watermark. I'm sorry for being the loser of the market economy. So we are given that the mass of the book is 1 kilogram. The coffee mug that the string is connected to is 500 grams or 0.5 kilograms. The book was released at a speed of 3 meters per second, and we're given the coefficient of friction, 0.5 being static and 0.2 being the kinetic friction.
Raymond, scroll upward so we can see the thing without the watermark blocking it.
Well, here's the problem. If I just scroll up, it's parts are still going to be blocked by the watermark in the first place. And if I try to make it above the watermark, there'll always be some tiny part that will be blocked, and there's not enough room for you guys to see the whole thing. But anyways, I just listed the forces here. So both the book and the coffee mug are affected by gravity and tension as well, except tension's upward for the coffee mug and tension's down left for the book. So relative from the book to the surface, there's normal force that's perpendicular to the surface, and there's a static friction trying to keep the book still. And then and even though there's tension on the book, kinetic friction is trying to push the book back up, even though it's kind of futile since tension and the gravitational force on the book is going to overpower this kinetic friction anyway. So parity looks for the distance, so so I'm using s equals v squared over 2a, assuming that v initial is 0, and the rest from v squared final equals v dot squared equals 2as. We don't have a, so we have to use Sir Isaac Newton's second law, which is acceleration equals force divided by mass, or more commonly known as force equals mass times acceleration, but we're isolating acceleration. So now after that, we have to find the net forces, and that's going to be the hard part. Dear Lord, I hope my speech impediment doesn't ruin this video. Okay, so the net force is going to go this way, down left. So anyways, we have to find the net force. So we have to find the tension because that's the direction the book is going. So again, I forgot to tell you guys that we have to split up the mass times gravitational force, gravitational constant of Earth to mg cosine 20 and mg sine 20. So yeah, and to get the net force, we have to get tension. We have to get the kinetic friction minus the tension, since tension's on the negative end of the x-axis. So yeah. So anyways, t will equal the negative gravitational force of the book times cosine 20 due to the tilt. But anyways, we also need to find the kinetic friction, which is the kinetic friction coefficient times the normal force, and we don't have the normal force either. So we have to use this equation. Normal force equals gravitational force of the book times sine 20 plus static friction. Static friction equals 0 since the book is moving. It's not static, so it's 0. And anyways, we can find the force of the book times sine 20. Even though it does kind of seem sketchy, the net force is 8.71 newtons, and then we do have to divide that by the mass to get acceleration, and the mass of the book is 1 kilogram. So it does seem kind of weird, but that would mean that the acceleration of the book will be 8.71 meters per second squared. Now we have to put this into the distance function. So we are given that the velocity is 3 meters per second, and then we calculated that the acceleration will be 8.71 meters per second squared. So now these are my calculations, so you guys might get different calculations. So I got 0.52 meters, and that's my answer for part A. And for part B, if the book is at its highest point, we have to find that if it stays or if it slides. So basically, if it yields or if it yeets. So we have to check if the net force, which is mg cosine 20, is less than 2.03 newtons, which is the friction force we calculated earlier from the Microsoft Paint when it was black and then there was yellow text earlier. But anyways, you get the point. So so we do have the mass, which is 1 kilogram. And then we know that g is 9.81 and not 10. And then we multiply these two, and then what I got would be 9.22 newtons. So this Boolean is not true, so therefore the book will yeet. So because 9.22 newtons, which is the direction that the book would go, is more than the 2.03 newtons that the friction needs to be in order for the book to stay. So the book will yeet. Well, anyways, if you like my video, please drop a dislike. And also, if you are peer reviewing this video, I made a lot of mistakes here. But if you put the watermark as one of them, dear Lord have mercy. I'm sorry for being the loser of the market economy. Okay, I can't change my financial status at the moment.